Grab your remote and let's
Hey, check this out. It's magnetism.
Bill Nye the Science Guy. Bill Nye the Science Guy.
T-minus 7 seconds.
Bill Nye the Science Guy.
Bill Nye the Science Guy is brought to you by Bar Magnets. You get 2 poles in every bite.
I'm Ed Weinberger, and I'm a doctor who works with magnetic resonance imaging, or MRI.
It's kind of weird because this big giant magnet can see inside your brain. It doesn't hurt at all, and the reason why I'm having MRI is because 5 years ago they found out that I had a brain tumor.
Well, Desiree right now is in a very big magnetic field, and she's in a magnetic field that is about 25,000 times the strength of the magnetic field of the Earth. The MRI behaves like a very large magnet with a north and south pole. Your body is made up largely of water, and most of that is hydrogen protons. And the hydrogen protons behave like tiny little magnets, and they see this big magnet, and they want to say, I want to line up with it, just like a compass lines up with the magnetic field of the Earth. And what we're measuring is the different rates of these little magnetic fields, these hydrogen protons lining up, and that translates into the picture that we see. The little knocking that you hear is actually the main magnetic field changing a little bit so that we can get a better idea of what's happening inside the brain. And this time, the images are coming up as if we've sliced through the body like a loaf of bread this way. And they're coming up in different colors because the molecules have rearranged themselves at different speeds. And that helps us look inside the brain. Here are the eyeballs up here. Here's one eyeball. Here's another eyeball. See how the colors change a little bit? But here they both are. Now, over here, we're down in the inside of the brain, and that's the area that we're really most concerned about. Over here, everything looks fine. So I think we're all done, Vic. Everything looks fine.
Thanks.
And in the magnetic resonance imaging, we can look inside the human body without having to cut or do anything bad like that. And she doesn't feel it. It's sort of cool.
Use a magnetic compass. It doesn't always point right to the North Pole. No, it points to something we call magnetic north. So if you look on a map like this, you'll find a little diagram that tells you the difference between magnetic north and the arrow pointing to the North Pole. Then you have to adjust your compass to get it to point toward true north, right to the North Pole. See, the magnetic North Pole isn't right here at the top. No, it's over here someplace. So if you're at, say, the west coast of North America, maybe near Mount Rainier, your compass doesn't point this way. No, it points a little bit that way. And if you're on the east coast of North America, your compass doesn't point that way. Now it points a little bit that way. And that's what we call the magnetic declination. So you have to adjust it every time you use a map and compass. So let's see. It's looking for Mount Rainier, right?
All right.
It's around here someplace, I'm sure.
Getting warm.
Sure it's
Warmer. Cold. Ice cold. Boiling hot. There you go.
Wow. There it is, right there. Hardly even needed the... We're aboard a big steel oceanographic research vessel, and here is the ship's compass. It's mounted in something called a binnacle. See, the steel ship would attract the compass, and the compass might align with a ship like this. But see these big iron spheres? Well, they're so close to the compass that they pull the compass back the other way and completely cancel out the effect of the ship. You can rely on a compass when it's mounted in a binnacle. Yeah, I remember back in '78, we were rounding the horn, lashed myself to the railing, and I kept my eye on that compass. That was by the days, baby.
grab your remote and let's explore. Let's move it. for some cool science.